time. My name is John Gibbs, principal here at WRTM, a landscape architect, very much an orchestrator. And Christine Reed from the city of Oakland is here, and would love for her to introduce herself.
Yes, hello everyone. Christine Reed, City of Oakland Public Works Department, Project and Grant Management Division. And we should also note our project partners, State Coastal Conservancy. Marilyn Latta is here. They've been really instrumental in helping support this project and advancing this exciting work that the team is going to present today.
Yeah, and we appreciate Christine Reed's leadership throughout this effort of developing a concept for Estuary Park. You're also going to hear quite a bit from Mario Accordino from ESA, kind of leading the bulk of the technical work on this living shoreline project. His colleagues, Louis White and Jorgen Blomberg as well from ESA. So thanks to all the partners here. I think our first slide here just acknowledges kind of everybody that's involved. There's been a number of other support partners on the project, Peter Bay, some other familiar faces here, Marine Taxonomic Services, Smithsonian, et cetera. Funding for the project coming from the city of Oakland, Measure DD. This is a park bond measure that's funding parks throughout Oakland. And that's kind of an important point. And of course, as Chris mentioned, the Maryland and the State Coastal Conservancy really appreciative of that grant. As I'm going to get into, this is first and foremost, this was a park project for the city of Oakland, delivering parks and recreation, but it's a waterfront site. And so this funding that was received from the Coastal Conservancy really allowed us to dig in with greater research to really kind of ground truth and understand what are the real opportunities for ecological restoration here on the site, and to really get this right. I think that we would not have been able to accomplish, the degree of certainty and feasibility that we've arrived at really without that support. Next slide, just high level introduces the project. We've been working at this for many years, and I think that the point here is that it takes a lot of years to develop these kinds of projects that are both park and shoreline components. A lot of years of engagement, talking about fields and talking about events and maintenance related to parks, but also really navigating feasibility, permitting strategies for living shoreline components. We will be building this project, but this is a real world project for sure, in that we're navigating phasing, we're navigating budgets, city politics, developer agreements. There's lots of complexities here that we won't necessarily get into in the context of this whole project. And I think next slide is really just the location. So where the heck is Estuary Park in the city of Oakland? Well, we are on the estuary. This is right at the mouth of the inlet to Lake Merritt, and an ecologically rich story unto itself. We're here just at outward of that, just northwest of the Brooklyn Basin development area, just a little southeast of Jack London Square. And this is a fill site into the bay. Years ago, it was Sunset Lumber, held this land for a number of years with shipping access, lumber storage, and they unfortunately added some pollution to the site as well. So this is a pretty typical urban site, both in terms of its site adjacencies, condominiums, public access, Bay Trail, pretty constrained site, major aquatics program here out of the Jack London Aquatic Center, historic pergolas and things on this site, but also an unfortunate legacy of contamination that really plays into how do we prepare a shoreline treatment. Next slide is, the park. And just wanted to state, this has all the components of a public park, the play fields and the dog parks and the picnic areas, and a pretty great vision. But from day one, there's been a recognition that on the bay we have a responsibility to create a resilient and an adaptive shoreline along with the Bay Trail. And a couple things that we did quickly was to pull the Bay Trail back from the shoreline just to give more space to how the shoreline can adapt, and then began a pretty integrated design process with all of our partners at at ESA and across the team to really understand, what are those opportunities and how do we realize this in the urban context of public access, of people wanting to get down to the shoreline. And so as we went through this engagement process, the next slide, we really learned how much a priority resilient shorelines were to the community. So top community priorities in our surveys out to so many different local neighborhoods, pretty solid underrepresentative representation within our communities as well. That public access and that resilient shoreline were really seen as key priorities. And I always love to point out that when you can have that be a higher priority than a dog park, it's saying something within our urban community. So a lot of support for this and a lot of support to prioritize some of those elements as the project begins to move forward. So we set out to then design this very integrated, very beautiful place with all the components of a park, and to really think of this in a very seamless way. And while this graphic is now a little bit out of date on the living shoreline side, this is still kind of, I think, pretty close and representative of what an integrated park and living shoreline can and should start to look like. Next slide. And I think here is where now we can get into where are we and what's been our journey with the technical design of the shoreline, as Mario is going to step in here to talk about what we found, the design iterations along the way, how maintenance and kind of long-term viability within the city of Oakland is also an important driver of our thinking here, where we are with our permitting process, and we'll wrap up with some great lessons learned, because that's kind of the point of this conversation with you all today, is that we're all learning and sharing, and we've definitely learned a few things along the way. So I'll hand it over to you, Mario.
Great, thank you, John. I'm going to talk a little bit about the early phases of the shoreline restoration design process. Here are a couple photos of the existing conditions at the site, and we're looking at the south shore of the project area adjacent to the Oakland Estuary. As you can see, it's a highly urbanized, degraded site that's armored on all sides, either with large rock or concrete slabs. So our goal for the project, first and foremost, was to create a sustainable and resilient shoreline that is adaptive to future changes in sea level rise. And then we have a host of other habitat-focused goals that are voluntary or funding dependent and really made possible through the Coastal Conservancy's Climate Adaptation Grant, as Chris mentioned. These are informed by regional policy and guidance and include balancing habitat enhancements with recreational and educational opportunities, increasing the overall shore biodiversity, and really using this site as a testing ground or a living laboratory for a variety of nature-based shoreline treatments. And the project team conducted a number of technical studies at the site. I'll just touch on a few here by some of our project partners. Marine Taxonomic Services performed scuba and side scan sonar surveys to document existing species and the characteristics of the substrate in the subtidal zone. Shayla Zabin's team at the Smithsonian conducted an intertidal assessment where they, unfortunately but importantly, identified the presence of the Atlantic oyster drill, which is a predatory snail that really led us away from focusing on oysters specifically as a restoration goal and more towards a general goal of overall shore intertidal biodiversity. And Peter Bay continues to be valuable in providing recommendations for a range of habitats and really stressing the importance of a continuum of habitats across the shore profile. So those technical studies led into this preliminary design plan, and you can see several living shoreline treatment measures in this early schematic. The estuaries to the bottom of the screen, the Bay Trail and the park are towards the top. You can see the eelgrass bed in green there, a rocky intertidal habitat zone, a gravel beach, and then a vegetated backshore area. And we'll take a look at two sections cut through this design as well. So here you can really see the aim of the project team to have a range of habitat types over a range of elevations. And I think these sections also help illustrate one of the constraints that we're negotiating which is, as John mentioned, the past industrial use at the site and potential contamination concern, which means for us that this project will not be excavating bayward of the mean high tide line. So a lot of those living shoreline features would need to be constructed through fill material. And that fill material, like the gravel beach shown in the gray color in the top section, would need to be retained on either end by retention structures so that that sediment is not lost to longshore transport. And you can see that retention structure in the bottom section composed of large rock. So when we presented this preliminary design to regulatory agencies, they strongly recommended that we reduce the amount of fill in the intertidal and subtidal zones and to soften the overall shoreline geometry. Another consideration when going through our design iteration process was an ebbmud easement that exists on the site, an ongoing geotechnical analysis, and how that relates to where we're able to place fill in the intertidal and subtidal zones. So with those considerations in mind, we produced an updated shoreline design plan, and this is currently in the 60% design phase. This is an illustrative graphic of those engineering plans. And you can see it has a lot of the same living shoreline elements, including the narrow fringing eelgrass bed and reef in the subtidal zone. And to quickly touch on some of the other elements, we have a transitional backshore that would be planted with a variety of native lowland meadow species that are burial and salt spray tolerant, a vegetated beach ridge that would contain anchored large woody habitat structures and California sea blight plantings, cobble headlands that would provide shoreline protection and also help retain beach sediment, and as well as the gravel marsh terrace on the western side of the shore. Both of those features would be capped with a top layer that integrates vegetation. The gravel beach remains, but here it's perched above that mean high tide line and contains some unvegetated backshore lobes that would direct public access to the water's edge, and a host of intertidal enhancements that we'll talk about. So here are the updated design sections. Just to point out, in that top one, you can see the perched beach in the gray color above the mean high tide line. In the lower section, that's cut through one of those cobble headlands in the dark gray color that's integrated with vegetation. And in both, you can see the narrow fringing eelgrass bed and subtidal reef on the left side of the section. So taking a closer look at this intertidal zone, we want to remove and reuse what we can of all that concrete debris that's above the mean high tide line. But then, hearing and incorporating the agency comments, we want to be selective and deliberate about how we're treating the intertidal zone below the mean high tide line. And so instead of wholesale excavation in that area, we'd be modifying those existing concrete debris slabs that are large and smooth and homogeneous, and breaking those up into smaller, more textured pieces, as well as selectively preserving some complex hard substrate that does exist on the project site, and maintaining gravel and shell hash material where that exists. So in addition to these sort of selective treatments and modifications, we're proposing to preserve a small but existing population of fucus or rockweed species that are present on site, and to augment that population with transplants from nearby donor sites. We're also exploring the idea of geopolymer reinforced concrete structures, and these would be formed by binding together some of those reused concrete fragments with stabilizing and texturing agents, so that we can create sort of complex three-dimensional structures that are stable in a marine environment and contain swim-through spaces and crevices and heterogeneous surfaces that are favored by intertidal life. We're also looking at more off-the-shelf precast tide pool units, these water-retaining features that are very similar in their aims to the geopolymer reinforced concrete, but sort of having these two features close together would allow us to compare and contrast these different approaches. So just some high-level lessons learned as we're continuing to work through this Living Shorelines project in a highly urban context. As we mentioned, there could be potential contaminants due to the site's past history, existing utilities that could put parameters on the earthwork that we're unable to enact. And then these steep and armored shorelines, which can be tricky to integrate with more gently sloping living shoreline treatment measures. And of course, the ever-present sort of concern of public trampling and vandalism of some of the more sensitive elements. But as John mentioned, we're really viewing the public component of this project as a big opportunity and provides us a high degree of access and engagement and education. It's also an opportunity in this setting to incorporate resilient strategies for sea level rise adaptation into a public park design. We spoke about reusing some of the existing materials and taking advantage of such a condensed site to test and evaluate a variety of living shoreline measures. I think we're probably at time, so I'll just leave that permitting takeaways box there. But that's been an interesting process that is ongoing as we prepare permit applications in this phase of design. Thank you.